That was from Friday, so then Mondays or today's is technically do the other 5. So if you don't have this done yet, yeah, that is misleading. I should rip that off. Yeah. The choose any 5 was for Friday, because I didn't want to overwhelm you guys. It's all good. Yeah, if it's out of order, that's fine. What's up?
When are we reviewing all the homework from last week?
I will. This week got really weird with math testing, and class is short today, so there's no time to really give you guys stuff back. Probably tomorrow. We might be waiting until Friday, because Friday. Hey, everybody, and thank you so much. Everybody needs to bring their textbook on Friday. Okay, we are covering them. So whether you've taken a 7th grade book or an 8th grade book out of this classroom, all books need to come back on Friday. Hopefully, we're going to be able to work quick enough that you guys can cover both books. And actually covering books is kind of fun. I have like a minor OCD-ness, and I really like once my book is like nicely covered in paper, then I can draw on it. I can do whatever I want with it. It's protected. I know I'm not going to screw it up. And the paper cover is better than the stretchy covers. I have kids that often complain, why can't we use the stretchy covers? If you try to Sharpie on a stretchy cover, you write on the book, and then you get to buy the book for $75. So this won't bleed. The Sharpie won't bleed through the paper. And then often we can easily write, like, if found, please call, whatever, like, inside your, or you can write it on the front if you really think you're going to lose your book or leave it at the library or something. And then it's really easy because if you put your cell phone number or your parent's cell phone number on this, if you take it somewhere and forget it, hopefully you'll get it back. But yeah, respect those books. They are worth $74 if we're being exact. And the district will charge you for them if you destroy it. Yeah. Then it's still here. If you haven't taken any books out of the classroom, that's good. Hopefully I get my extra Math 7 books by then. But right now I didn't have enough Math 7 for you guys. I showed you a spreadsheet last week and said, hey, if you care, here's your book numbers. But I didn't think it was big thing. Mainly we use the ebook because I don't want to say you guys have to manage 2 different textbooks. That's a little excessive. That's extra. Like that's a word you guys use now or something. So yeah, I wanted to make life easier than that. Cards. We've not talked about cards yet. Right? Yeah? No? Maybe?
No.
Yes. So you guys are my 1B class. And this is just going to still say Accelerated 7, even though you aren't. And did you come to the Alpha or Beta on Friday?
Beta.
Okay, I'll have to change that. And 2 of you, I still need to make your cards. But Mr. Smith, oh so kind to Mr. Smith, printed out everybody's names. And I, because I don't like how small they are, tape them on here. And as we go through class, this is how I make sure I check in with everybody. So if you don't get called on a day, your card will be like coming the next day or the next day after that. So like if I go through this many cards today, they will go on the bottom. Sorry. Sometimes I go straight from the card. Sometimes I will call on people. But what this helps me be able to do is, as we're trying to answer questions, no one needs to raise their hand when you have the answer because I let you guys have time to work. And then when we're ready to bring it back together, I'll just call on somebody, just random from the file. So right now I'd be Brayden. And then George would be after that. So say I call on Brayden, and he either was at the bathroom, using the restroom, doing something, or just doesn't have the answer, isn't ready, or doesn't want to answer, you can pass. So if Brayden wanted to pass, do you think I just toss his card to the side and like he gets a free pass for the day? No, I put his card back in the deck, and I will then come back and call on him later. I would move on to George and see if George has the answer. So all you have to say is pass. I guess. You don't have to justify why. Now I might ask you a question just to understand why you're passing, but you don't no shame in passing, anything like that. We don't all always have the answer. That's just like the truth, and we don't all work at the same pace. So if your hand is up while we're solving or working through a problem or something, I'm going to assume that means you have an issue, right? So we're not raising hands necessarily for the answers. Now if we're like talking together, we're having like a class conversation, and I ask a question, and like, yeah, then I'm going to expect your hand is for an answer. But if we're in the middle of solving, and you stick a hand up, I'm going to assume it's some kind of issue, and probably come over to you or call on you or something like that. We will for sure get done with 114 today. We'll probably start 121. There's a little bit of setup for that, because we're going to do probability. Probability is awesome, and probability is also how you win at all these games. So one of you guys, I forget if it was this class or it was Math 7 class, on our homework we were talking about games being fair or not, and for Monopoly, they put like, oh, I'm not quite sure if this is fair, and I wrote in there like totally not fair, because depending on when you like set out of the gates, and depending on what rolls you get, depends on who gets around the board fastest over to the corner that is cheap enough that you can buy it pretty easily, but has high rent once you start putting houses and hotels on it. So, like, in my opinion, Monopoly is totally unfair. But if you understand probability of the dice roll, you'll know a lot more about where you should be headed and where, like, what's probably gonna happen. Because there are numbers when you roll 2 dice that are way more likely than other numbers. What number is like hard to get when you roll 2 dice? Same guys, right? A 2, a 1, and a 1. That's the only way to get a 2, right? A 1 and a 1. And I'm probably giving away too much right now. What other number is there only one way to get it?
12.
The 12, right? The 6 and the 6. If I heard somebody say 6, how can I make 6 on dice? 3 and 3, 2 and 4, 5 and 1, and then I can switch around the 5 and the 1, or I can switch around the 2 and the 4. I can actually switch around the 3 and the 3. If I have a red die and a green die, I have a lot of ways to make 6. I only have one way to get 2. Dice are rigged. Well, not really rigged, but some numbers have a much higher probability than other numbers. Does anybody in here play Catan? Okay. Catan is all based on, this just goes to show that you've got some sweet nerdy parents that have shown you a great game. Catan is based around the biased dice rolling numbers. It tells you the probability, and if you didn't know this, about to blow your brain. The Catan board pieces, the number pieces, have like the number, and then there's some dots under here. That tells you how many ways that number is made on the die. So if you build on a property that is a 2, it has 1 dot. Because there's one way to make a 2. But if you build on a property that has an 8, there's a lot more ways. 7 actually is not part of the game. Because 7 is okay, it is part of the game, and Simon, I'm coming over to you. 7 activates the robber, which is a different character that you move and then you steal. Because 7 is so likely, they had to give it an alternative. Right? They didn't want to give it like a board piece. Simon. Yep. And that depends on what edition you bought too. My brother just found a 1996 in the plastic still. Like the cards are still in the plastic. Now it's not worth that much. But yeah, it's older than all of you guys are. Catan set, the numbers are actually on the hexagons. They aren't their own pieces. They're on the hexagon. So it controlled resources. So like if you get a handful of sheep, it's like who wants a handful of sheep? Back then they hadn't like made these modifications to the game. So it's really interesting to look at different iterations of the game. And then like you play D&D, right? You don't just use 6-sided dice, right? There's yeah. The 4-sided die, those are really weird to roll because how they bounce around.
A 3-sided die.
Yeah, yep. Yeah, we'll do some sweet die work this year, but like I have a bunch of different dies here if you ever like want to look at. Actually, these are all the same faces, but these are fraction dice. So they don't have numbers, they have fractions on them. So if you want to play with numbers and practice like adding fractions or multiplying fractions or whatever, if you're like bored at AOR extensions, come and borrow my fraction dice if you want. We should probably do some class, I guess, and stop just talking about board games. Real story though, anyone here play Set? Card game, Set, you play Set? Love it. So if we have time, and I doubt we will today, I'll probably show you guys on Friday when we're doing book covers. I have a little video about the game Set to show you because it's math. It's a straight up math game. But it's really easy to understand once you understand it. And I have Set, and if people are interested in it, I will buy multiple copies for school. Like I would love, because like people keep coming in to borrow my chessboards. Set is a game that as many people can play as you want. I mean, the more people that play make it a bit tougher because it's a speed-based game. But you could have a table of like 4 or 5 people all playing the same game together. which I think is kind of more fun than just two people playing chess and people watching it. We made a graph, right? We remember this? We got to go back in time a little bit to last week. We made a graph right here for Newton's revenge. And actually, I'm going to slide my textbook up onto the TV. So if you were with me, we're talking about problem number 126. And there were some problems in your homework. Was it shoe size and height, I think? So when we're looking at any graph, actually, so go ahead and throw a label in your notes, even if you're extending on those previous notes. Graphs. What? Oh, they're darn 8th grader. Sorry, I lost track of time. We started talking about Catan, and
It's over already? Will we assess it?
graphs. Now, in your homework, yeah, cover your coughs, wash your hands. In your homework, you have shoe size and height.
Good morning, Gwendolyn Armstrong. Please come to the office. Gwendolyn Armstrong to the office, please. Thank you.
By the way, somebody asked. This is the church I grew up at. Like I'm Methodist. Grew up in that church, so that's what's on this mug. Somebody was like, "Is that just some random building?" But it's actually, it was pretty sweet. It's like an old, like big stone brick, nice bell tower. We would climb up in the bell tower. Pretty fun. So, did your homework tell you how to label your axes? And first, I was waiting for a hand to go up. We're going to do this class just because we're the advanced class. What is an axis or an axis? If it's singular, we say an axis. When?
It's the origin.
The origin point is actually right here.
Yeah, but then you have the lines.
Ah, so the axes are the lines, right? Do you know which axis this is going horizontal? Sam? And Simon, the other one?
Y.
So please label your axes X and Y. Now I'm going to throw some information at you that the book doesn't give you yet, but I want you to know what this is called because I've already told a few of your classmates. Question? If you're doing three-dimensional. Yeah, so the z-axis, don't write this and don't think too hard. If we were to graph in 3 dimensions, it comes out. So imagine a room, wall, floor. So you would go like 3, 5, 7, but you have to have this certain type of paper to make it actually look right. But this is your 3rd dimension. The other way that math teachers try to teach it is like you can use your hand and try to see like all 3 axes, but I can never do it very well. I forget which hand and how you do it. But that would be graphing in 3 dimensions. If you care, this is the z-axis, but you don't need to know that yet.
Not yet.
Good question. So, trying to decide how to. So your homework didn't tell you what to put where, right? If I say that we have height here, and we have shoe size here, what do you think happens to how high my point is as I go to the right? As my height gets taller. So maybe out here we'll say like, here's your 6 feet. Like most people maybe grow to be like around 6 feet tall. As I approach 6 feet, what do you think happens to my shoe size? Goes up, right? Yeah. So we would predict. Now, if you did this in your homework, you end up with some points all now don't like this is not matching your homework. We end up with some points scattered about, right? Small kids, short height, small shoe size. Big people, tall height, big shoe size. And then it asks you, is there a relationship? Right? And this is the question that a couple people were having issues with. Is there a relationship that we see? All it really is asking you, could a line relatively model this behavior? Would a line that increases x and increases y be appropriate for relating height and shoe size? Yeah. So this is what we call, and you might want to write this down, line of best fit. It's not the line of perfect fit. It's not the line of absolute matches. It's the line of best fit. It relatively models what we're trying to do. You with me, Connor? You writing this down in your notes? So just grab sheet graphic. Wait, do you need graphic? Okay. Just start a new one. You can always start a new one. Always an option to start a new page, guys. Now, I think you can, hopefully you have some space on your paper. I'm going to scroll a tiny bit. To give you more explicit, which means like more details, information about how these axes work, your shoe size, according to how we set this up, depends on how tall you are, which would pretty much make sense. Could I turn that statement around and say how tall you are depends on your shoe size? Like, can I not get any taller without my feet getting any bigger? No, like, yeah, my height does not necessarily depend on my shoe size, but I bet my shoe size won't increase if I don't grow, right? Like, I would need to grow first. How we talk about this in mathematics is this is the dependent variable, and this is the independent variable. I should see every pencil moving, because I doubt that you were able to predict what I was going to write. What that really means, X can do whatever he wants. I can get taller on my, like, it can just happen, right? And my shoe size won't necessarily go up, but my shoe size is waiting or depending on my height. So if we relate this to the graph that we made, we had height and reach. Do you think your reach, which really is up here, but do you think your reach can change without your height changing? Or did we maybe set this graph up wrong? What we're really asking is, what do you think should be independent? What do you think could change on its own and then the other thing relate to it? It's a weird question, right?
Yeah, because like, I mean, there's some people that like their arms can like go down to their knees.
Yeah, your arms might grow without you getting taller.
Yeah, like it kind of depends on like.
Okay. What if instead I make this question easier? You guys will learn this year. I really like pizza. I really do. White sauce, chicken, bacon. Real good.
I'm sorry, meat lovers.
We're going to cook a pizza. And what we care about is how long it takes and how hot it is, right? Because it's frozen and I'm not about to eat a frozen pizza.
Do it.
So we have time and temperature. I want you guys to try to figure out where would I put time and where would I put temp. Can the temperature just change on its own? Or does time change on its own? Take a moment. Talk with your group if you need to. Take a moment.
Time changes everything. I made my I'm just going to use my XY graph. Very small. stop for you.
Time will never stop.
Although I just
Sorry, guys.
I just wish I could.
George, where should time go?
Time go on the x-axis.
Time is independent. And it's easier if you try to talk about both. I know that might seem weird. It's easier if I say the temperature depends on time. Right? Because if I'm cooking the pizza, I start frozen, right? So I start at like 30 degrees or whatever your freezer's set to. And let's graph it with red. Time, it takes it a minute to get hot, but then it gets hot, and then I probably shut off the oven and let it cool down a tiny bit, and then I eat. So here is like that whole like 30 minutes or however long it takes my pizza to cook and then cool down a tiny bit. That time can change on its own. If the power goes out and my pizza stops heating up, time is still gonna keep changing. So what we could say is temp depends on time. If I try to flip that statement around, it doesn't make sense. The time depends on temperature. It doesn't make sense. So figuring out which one is dependent and which one is independent, we can just relate those statements. Does that make sense? Are we getting stuff written down? I see a lot of hands in pockets. I don't want to keep having to give people a handwritten invitation to it. Yeah.
You can just say that the time is sometimes you look at the box and it says like 10 minutes and then it takes like 13 minutes.
Mm-hmm. Have you ever seen Space Jam?
Yeah.
Yes.
Time keeps on ticking, ticking, ticking into the future. Yeah? No? Has it been too long since you've seen Space Jam? That's a Space Jam song, right? Alright, good question. Why? So I'm skipping over some of the stuff because again we're the accelerated class and today we have short class. Why did I only draw one quadrant? And to understand that, we got to remind ourselves what the quadrants are. Which I've had a couple people asking really, really good questions and double checking on things. Our quadrants, we have 4 of them, are numbered kind of weird. Go ahead and set axes here.
Oh my god, graph.
What's quad mean? That's easy. 4. Here's what's weird. This is quadrant 1. Then act like a clock. This is quadrant 2. We go clockwise. This is quadrant 3. And this is quadrant 4. And to label it, we use Roman numerals.
I thought it was the other way.
I know a lot of people do.
But
Because I remember getting caught last year, it was in C.
Good morning, Phoenix. Please pardon the interruption. For our Cardinals athletes,
Am I reversed?
no Cardinals
Oh, I wrote it up
gymnastics
there backwards.
or
Yeah.
Cardinals cheerleading today. There's no Cardinals gymnastics
Well, that's funny.
or Cardinals cheerleading today.
Hold on, erase that. I gotta double check on this. So I teach 3 different math classes, right? And sometimes I get backwards on things. Graph. Yeah, sorry, I got my brain mixed up. Sorry, and this is the problem with me teaching beyond what the lesson wants you to know. All the lesson wants you to know is that it is quadrant 1, and then I decide to teach more, and I'm not thinking the right things. Where the heck is our book? Oh, here we go. I do have too many tabs. What's up?
Do you have any extra backboard that comes up with USB?
I don't think so. Well, if I do, it'd be in the drawer where all the cords are. Yeah, I mean, check the drawer.
What drawer?
Right cabinet, top drawer. So, it actually, sorry guys, and I love that you guys called me out on that. It's that. Yeah. Sometimes I get it right. So I couldn't remember the quadrants, but I can draw a straight line, I guess. Oh,
And so there's
winning somewhere. Here's what we really care about. Quadrant 1 is positive everything. Quadrant 1 is positive everything, which is why. Yeah, thanks. That's why we use it for situations like our roller coaster. Can anyone have a negative height? Can anyone have a negative reach? Can we go backwards in time? Can my pizza get like a, well, I guess my pizza could end up going to a negative temperature, so that's a bad example. Depending on what I do, if I put it in the deep freeze, I might be able to do that. Quadrant 1 is positive everything. That's still not negative height, it's just like the wrong direction. Your height would still be going positive though. Alright, real quick, I only have 10 minutes left with you guys. Well, I have like 7 minutes left. Are there any big questions from your homework? Not not this 114. Oh, yeah. So I got last week got a little crazy on Friday too. I had it on the board, but then I didn't announce it because we took that little mini mastery. I need your homework from last week, not the one that you're still working on 30 to 40, but the rest of them. And this is the perfect thing to do right now with 5 minutes left. So you should have like 111, 112, 114 from the 7th grade book. And then 112 from the 8th grade book. That should be your order. So I'll write those up here. From CC2, you have 111, 112, and 114. In CC3, yes. So if you already turned this in, now some people I said like get it back and just staple them all together because I didn't end up grading 111. If I had your 111, I'm gonna staple them together for you. I'll match them up. So if you already turned this in, you're good. So some of you might have already done this. And then you don't turn in, but you have and are still working on 114. Even if you're done, keep it because it's not on this grade. I've already put in like my grade book what I'm checking. And those go in the second bin down. I have a found homework here, and I have a Teak Slack homework. Teak, this is your 112. I don't know which book though. I don't know whose this is. It's really jumpy. Is this yours? It's the same. It's all good. So get your name on it now. Hopefully you didn't do that twice. Cause crap, we don't have any. Yeah, we're just gonna show you. So I'll show you the video that I want to show you, but then we probably won't have time to watch it. You do not turn in this homework that's written in red. That is still assigned for tonight. We didn't have math yesterday. There was no math class. So that's why I just put the same assignment kind of crossing both days, because we did not have math because of the safety drills. So, set. Maybe I should just look up an image. So, I want to start teaching you guys set because it's a really great game about set theory.
No, we've played this.
Well, you come from 12 different elementary schools, so you've maybe played this. So as you guys turn in your homework, I'm just going to drop some knowledge on you because I have 2 more minutes. Knowledge bombs are great. A set. A set is made, and this is a mathematical branch of set theory. A set is made when we look at all 4 characteristics, one at a time, and they either have to all match, like all 3 cards match, or all be unique. So I cannot have 2 cards with 2 items and then 1 card with 3. That wouldn't work. I could have all cards with 3 items, or all cards with 2 items, or all cards with 1 item on them, or a 1, 2, 3. So if I look at my 3 item cards, then I look at the other characteristics of shape, color, and fill, like shading. I either need to make them match or be distinct. George, you see a set?
Yeah.
Come circle it. So you play this at home or you play it at school?
Wait. Did I see one? Oh, dang it, I blanked it. Oh, here it was.
That is not a set.
Oh, no, it's not. You're right.
Why?
Because
He had 2 filled and 1 open.
Never mind. That's not a set.
Do you see a set?
Yeah.
Come here. This game's hard to learn, but it's like once your brain figures it out, you're good. That is not a set. This is a hard game to learn. Open, open, strike. See how the 2 match? And you can try. This might be a picture of the no set layout. Like there might not be a set up here. 2 purples, 1 red.
I don't think there's a set.
Now, here's the cool thing as we start to talk about probability tomorrow. I'm going to bring my game set. You don't have time. I'm sorry, guys. Hold on. Give me your set was designed so that in order for you to have a board of 12 cards and there not be a set, your odds are like 1 in 42,000 or something crazy. There's almost always a set to be made. So, you got no more time. I'm sorry. I got to respect the teachers that you're headed to. That's the end of our class. Have a wonderful day. If you want to try one, come up here real quick. But
I think that is one. I think that's yours.
Wait, no.
There's none in there.
Right?
No, because they're both red. Yeah,
I don't see one yet. That doesn't mean there isn't one. I haven't played in a while.
I have
One.
there is.
This might be the example of no set.
I see one.
Like we look here. This is a different board.
Wait, can you go back?
Now you guys got to leave anyways. Here's a set. Open, closed, striped. Green, red, purple. 3s match. And so it either has to match or be unique. So, colors, all unique. Numbers, all match. Shading, all unique. And then, I forget what else, but you guys got it. Yep, open. Did you see one here? Hold on, let me clear the ink. 3, 3, 1. That is not a set. I think this is a picture where there is no set. But actually, that's actually a better challenge. Like, is there a set here? Like, there may or may not be. All right, you gotta go. I'm sorry, Connor, you gotta go. You're heading to a class. Connor, I'm not gonna ask you again, bud. I love your excitement, but I gotta respect the other teachers and get you guys out of here on time.